Alternating electrical currents create electromagnetic waves. If you've got an ordinary FM radio, then they have a frequency 80 to 120 megahertz. And hertz means 1 cycle per second. So we go up and down within 1 second. So 80 to 120 megahertz means 80 to 120 million times a second. A very, very fast signal. If you've got an old long-wave radio and you like listening to the shipping forecast on Radio 4, which is about the only thing that's still transmitted on long-wave, then that operates at 30 to 300 kilohertz, 1,000 times a second. Still very fast. There's also, these are standard official international terms for frequencies. There's one called super low. You can't buy radios in the shops that pick this up. 30 to 300 hertz times a second. 30 to 300 times a second. Now, perhaps the electrical activity in the brain could be detectable in the same way. Maybe these pulses of activity going down the neurons could be generating radio waves, and a brain that knows you very well, that is tuned to your thoughts, can pick up your frequencies. It can pick up the massive panic of a trauma that you get when you're severely injured, some distance away in space. Well, here are the frequencies of the brain waves that Berger identified. We've seen alpha, the second one down there. There's also beta, the second one. There's theta, there's delta. Alpha waves are in the frequency of 8 to 13 hertz. So that little timing signal was probably tenths of a second. We've got 8 to 13 times a second. Beta, a bit faster, 13 to 30 hertz. Theta and delta, very much slower. And in fact, delta waves are associated with deep sleep. And there we've got half a hertz, so that's once every 2 seconds, up to 4 hertz. And you can see how the wavelength is stretching out, and the amplitude is getting bigger as well. So the range within which we're picking up these brain waves is half a hertz up to 30 hertz. That is lower frequency, slower frequencies than even the super low that I talked about. But there is a term for it. It's called extremely low frequency. You can't go and buy an extremely low frequency radio. But some people use it because the longer a wavelength is, the further it travels. You might have experienced, if you've got an FM radio, if you go into a room like this where there's lots of concrete and steel, or you go through a road tunnel in a car using an FM radio, the signal cuts out. So if you drive to Cornwall and you're listening to Radio Devon, it's not just that it's Radio Devon stops at the border. When you go through the tunnel in Saltash, you lose the radio signal. FM radio can't get through that barrier. The short frequency gets blocked by the metal and stone. Longer frequencies will penetrate more things. So Radio 4 still transmits on long wave because it goes through hills and buildings. It travels a huge distance out to sea. And fishermen in their trawlers can still pick up long wave radio, even though FM radio doesn't go much further than a couple of miles offshore. Extremely low frequency radio waves in that sort of tens of hertz range is used to communicate with subpolar nuclear submarines traveling beneath the ice caps that might be a kilometre thick. So you have to have a very long frequency that can not only get through the ice cap but also through all that water. They can do this because they can trail a great big long antenna behind them. And that's the other problem with radio waves. The length of the aerial you need is driven by the frequency you're picking up. Very high frequency things like FM radio don't really need a huge aerial sticking out the top of your radio. The radio itself acts as the aerial. Bluetooth and Wi-Fi, very much faster in the gigahertz range. Your phone doesn't need to have an aerial sticking out of it. It's got the phone itself has the aerial wrapped around it. Nuclear submarines using extremely low have to tow a kilometre-long wire behind them to pick up their signals. And in fact, when we get to that length of signal, the distance the wave travels in a 30 hertz signal is twice the diameter of the planet. So if you were going to use or argue that telepathy worked by picking up people's radio waves from their brain, we'd have to have very long hair, twice the width of the planet, to act as an aerial to pick up our brain waves.